Okay, section 4.2 is on the unit circle. The unit circle will be fundamental to memorizing certain trig facts as we go through chapter 4 and as you go through calculus and other classes as well. Before we get to the most famous positions on a unit circle, what is a unit circle? A unit circle has a center at 0, 0. So if I look at this right here, the center is at 0, 0. The radius is 1 unit. That's why it's called the unit circle, because the radius is 1 unit long. When you graph an angle on the unit circle, it should be in standard position, meaning the vertex is at 0, 0. It starts from the positive x-axis. So if I wanted to mark theta, theta could be this angle right here. Okay, normally you look at ordered pairs on the unit circle. So let's say this point, let's call it xy. I can use the unit circle to evaluate the sine, cosine, tangent, and other trig functions of that theta by using the unit circle. Okay, I'm going to draw an altitude going down from xy so I can make a right triangle. I'm going to redraw that triangle over here. Okay, now because this location is xy, then I must have gone to the side x, which means the length of that side is x. Because this is xy, if I go from here to here, this is a distance of y, so this side must be y. Now the fact that makes the unit circle awesome is that because this is a unit circle, the radius is 1 unit. So the hypotenuse has to be 1. Okay, if you remember your sine, cosine, or your SOHCAHTOA, or whatever it is, if I want the sine of theta is the opposite over the hypotenuse. So the opposite is y. The hypotenuse is 1. So the sine is going to be y over 1, which really just simplifies down to y. So the sine of theta is actually just the y coordinate if it's graphed on the unit circle. Okay, the cosine of theta is going to be the adjacent over the hypotenuse. So if I were to start from theta here, the adjacent side is the x, the hypotenuse is 1. So the cosine is x over 1, which really simplifies down to x. So the cosine of theta would actually just be the x coordinate here. Okay, that fact that the cosine is the x coordinate and the sine is the y coordinate when it's on the unit circle is how we are going to evaluate different functions at different places in our head. Now, if you have seen the unit circle, what we actually think of when we hear unit circle is a circle that has all these points labeled on and all these measurements on it. Okay, so we are going to label this circle with the degree and radian locations and the ordered pairs of each of these points. These are significant points because they represent special triangles. Okay, I don't normally use degrees, but I'm going to label it both ways today because it's the first time you're seeing it. Okay, so before I label the ordered pairs, I'm going to go through and show what each point on this circle represents in both degrees and radians. Which one? I'm going to do radians first, though, because I want you to think radians first. Okay, this line here represents 0. It also represents 0 degrees. Okay, I know that a full circle is 2 pi radians, which means half a circle is pi radians, which means this is pi radian line. If this is the 0 line and this is the pi radian line, then if I go halfway between, this is pi over 2. Okay, I'm going to go with the pi over 2's as if this is 0 and this is 1 pi over 2. This is 2 pi over 2. Then this must be 3 pi over 2 down here. Okay, which line am I going to label next? I'm going to label all the fourths. Okay, if this is 0 and this is pi over 2, then halfway between 0 and pi over 2 should be pi over 4. So this point right here is pi over 4, or that line actually, because it's really just the angle. Okay, I'm going to follow this along. This is 0. This is 1 pi over 4. This is 2 pi over 4. So this is 3 pi over 4. I'm going to keep going. That makes this 4 pi over 4, which is pi. That makes this 5 pi over 4. 6 pi over 4, which simplifies to this. And then this will take me to 7 pi over 4. And then if I were to keep going, this would be 8 pi over 4, which is 2 pi, which is a full circle. Okay, now these next little lines, I'm going to follow these lines. There's 1, 2, 3, 4, 5, 6. It's dividing pi into 6 pieces. So each of those represents pi over 6. Okay, so from here to here, that's pi over 6. This is 2 pi over 6. 2 pi over 6 simplifies to pi over 3. This is 3 pi over 6, which simplifies to pi over 2. This is 4 pi over 6, which simplifies to 2 pi over 3. What was I on? 4 pi over 6. This is 5 pi over 6. 6 pi over 6 simplifies to pi. 7 pi over 6. 8 pi over 6 simplifies to 4 pi over 3. 9 pi over 6 simplifies to 3 pi over 2. 10 pi over 6 is going to go to 5 pi over 3. 10 pi, what was that? 10 pi over 6. This is 11 pi over 6. Okay, and if I kept going, I would get to 12 pi over 6. 12 pi over 6 is 2 pi, so I finished a full circle. So my angles are probably correct. Okay, I'm going to relabel those in degrees. And then I'm probably not going to label the degrees again, to be honest. This is 0 radians. That also makes this 0 degrees. I could tell just by looking at this that this must be 90 degrees. This is 180 degrees. 180 plus 90, that makes this 270 degrees. And if I came all the way back around, I would get to 360 degrees. Okay, let's consider the pi over 6 lines. Okay, this is dividing the 90 into 3 equal pieces. So 90 divided by 3 means they're each 30 degrees. So this is also called 30 degrees. 30 plus 30, now we're at 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210, 240, 270 already labeled. What am I at? 300 degrees, 330 degrees, and if I kept going, I would get back to 360 degrees. Okay, what am I missing? I'm missing pi over 4. Since pi over 4 is between 0 and 90, that must be 45 degrees. 45, 90. 90 plus 45 is 135 degrees. Plus 45 is 180. Plus 45 is 225. Plus 45 is 270. Plus 45 is 315 degrees. Okay, so each of these locations, those lines can represent an angle in degrees or in radians. Okay, now we need to get to the part that matters, the ordered pairs. Okay, to start with, this is the unit circle. So I'm going to use the fact that the radius is 1 to get the 4 easiest points on the graph. Unit circle, this must be 0, 0, which means if I go to the right one, this ordered pair is 1, 0. Okay, if I go up to pi over 2, since this is 0, 0, and I'm going up 1, this must be 0, 1. If I go to pi, that must be -1, 0, because I'm starting from the origin. And if I go to 3 pi over 2, that's 0, -1. So I already have 4 of the points labeled. Okay, now let's consider one of these lines. Let's consider the 45-degree ordered pairs. Okay, so I'm looking at this guy right here. I want to figure out his ordered pair. So on the side, I'm going to do a little sketch to help me out. Okay, I'm considering the 45-degree triangle that's formed if I were to draw it right here. Okay, the one thing I know about this triangle is the radius is 1, so this must be a 1 right here. I want to figure out the missing side so I'll know the x and y coordinates. If you happen to remember your special triangles, this would be x root 2, which would be x root 2 equals 1, 1 over root 2, and I would get root 2 over 2. If you don't remember your special triangles, then we're going to use the Pythagorean theorem. Okay, since this is 45 degrees, this is also 45 degrees, so this is a isosceles triangle. Let's call this A and A. Okay, if I do the Pythagorean theorem, I get 2a squared equals 1, a squared equals 1/2. I don't care about plus or minus because I'm not going to have a negative on a side. Okay, 1 over root 2, I'm not going to leave it like that. I'm going to rationalize the denominator. So root 2 over root 2. I get the missing side is square root 2 over the square root of 4, which goes down to 2, which means both of these sides are the square root of 2, which means the ordered pair at 45 degrees or pi over 4 is going to be square root 2, comma, square root 2. Okay, you're going to end up memorizing that because that's a lot of work to remember every single time. But if you forget, you can always draw the special triangle and find the missing side. Now, because I know this ordered pair lines up with pi over 4, I now know the ordered pair that lines up with 3 pi over 4, 5 pi over 4, and 7 pi over 4, as long as I am respectful of my quadrants. Okay, so if I go to 3 pi over 4, it's still making a 45-degree reference angle with the 180 degrees. But now I'm in quadrant 2. Since I'm in quadrant 2, the x is negative, the y is positive, but the distance is still the same. Okay, I'm going to go to 5 pi over 4. Okay, now I'm in quadrant 3. It should be the same values, except for it should be negative, negative. And then in quadrant 4, I have 7 pi over 4, so that's positive for the x, negative for the y. Okay, now I just need to figure out the ordered pairs for my last two missing points in each quadrant. Okay, to start with, I'm going to consider this point right here. That's 30 degrees from the positive x-axis. Because this is a unit circle, I know that this is 1. Okay, now if you remember your special triangles, the hypotenuse is twice the length of the short side. So if that hypotenuse is 1, the short leg must be half. And to get the third side, it was the short leg root 3. So I'm going to get root 3 over 2. I could also use Pythagorean theorem, but I don't want to. But I'll do it in class if you have questions. Okay, so the ordered pair at 30 degrees, the x is root 3 over 2. The y value is 1/2. Okay, now that I have that one, I can label all the corresponding points in the other quadrants. So if I go straight across the y-axis, I get this must be negative root 3 over 2, comma, 1/2, because you can see these have the exact same y values, and they're just reflections. Okay, let's go to the next quadrant. Okay, so let's see. This is negative root 3 over 2, negative 1/2. And then over here, I have positive root 3 over 2, negative 1/2. Okay, now I only have one more triangle. I have to consider the 60-degree mark. Now, I actually already figured out the 60-degree mark. If I took this triangle and I rotated it, which I don't know how to do virtually on my iPad, so turn your head sideways. If you turn your head sideways, now the x-coordinate is 1/2, and the y-coordinate is root 3 over 2, which kind of makes sense because this point is a lot lower than this point, so the y value should be higher, whereas the x value here should be lower. Okay, so I'm going to go ahead and put those in the other quadrants. Okay, this is the unit circle we normally think of when we say unit circle. At some point, you will memorize this or have some image in your head that's going to help you evaluate functions. And we're going to use it to evaluate functions shortly. Okay, we just labeled that giant unit circle, but why did we do that? Okay, the point of it is to actually help us evaluate trig functions without a calculator. So if you look at example 1, we are going to evaluate these trig functions using the unit circle. If you remember the fact from above, which you can still see, but I cannot, and that was that the sine of theta is equal to the y-coordinate if it's on the unit circle, and the cosine of theta is equal to the x-coordinate if it's on the unit circle. Okay, so let's see how that plays into this. Okay, so I'm going to figure out what the sine of pi over 3 is. Okay, so let's find pi over 3. Actually, no, first let's look. The sine is going to be the y-coordinate. I'm just going to make a note because this is our first time doing this. Okay, the sine of pi over 3 is going to be the y-coordinate on the unit circle. So let me go to pi over 3 on the unit circle. Pi over 3 is right here. Okay, if I look at the ordered pair, it's 1/2 comma root 3 over 2. The sine of pi over 3 is going to be the y-coordinate. So the sine of pi over 3 is going to be the square root 3 over 2. Okay, this is what the unit circle is for, evaluating trig functions. Okay, let's consider the next one. I want to find the cosine of 5 pi over 4. Now the cosine is going to be the x-coordinate on the unit circle. Okay, so let me go to 5 pi over 4 on the unit circle. Where's 5 pi over 4? There's 5 pi over 4. Okay, let me look at the ordered pair. Cosine is going to be the x-coordinate, so that's the first number right here, which means the cosine of 5 pi over 4 is actually negative square root 2 over 2. Okay, let me consider the next one, the cosine of pi. The cosine is the x-coordinate, so let me find pi on the unit circle. Here's pi. The cosine of pi would be the x-coordinate. The x-coordinate is -1, so the cosine of pi is -1. Let's try one more. Okay, the sine of 11 pi over 6. Remember, the sine is going to be the y-coordinate while it's on the unit circle. So let's find 11 pi over 6. Here's 11 pi over 6. The sine of 11 pi over 6 is going to match the y-coordinate. So the sine of 11 pi over 6 is -1/2. Okay, now there are other trigonometric ratios than just sine and cosine, and they also can be found using the unit circle. Okay, so the ones that we already found were that cosine of theta is the x-coordinate, the sine of theta is the y-coordinate, the tangent of theta, if you go back to the original triangle we had drawn, it's the opposite over the adjacent, which ends up being y over x. Okay, there are 3 other trig functions. They're the reciprocal trig functions. Okay, the reciprocal of cosine is secant. I'm going to write it out in case you've never seen it before. The secant of theta, but we abbreviate that as SEC theta, is the reciprocal of cosine. So I'll write 1 over x, but depending on what the cosine is, you could just flip it as well. Okay, the reciprocal of sine is cosecant. I'm writing it out so you can see it written in case you haven't seen it before, but the abbreviation is CSC. Okay, and cosecant is the reciprocal of sine, so it'd be 1 over y, or the reciprocal of whatever the y value is. And the reciprocal of tangent is cotangent, which we abbreviate as COT, but we still call it cotangent and not cot. Okay, since tangent is y over x, cotangent is x over y. Okay, and these facts only work on the unit circle, and they're a shortcut for when we're on the unit circle. Okay, so for the next example, we're assuming this is on the unit circle, and it should be indicating a direction for the theta, to be fair. Okay, I'm going to find the trig ratios for this angle here, and you'll notice they labeled theta here, but they could also say sine of t, and it would be the same because the measure of the arc is the same as the central angle. Okay, so if I want the sine of this value, and because this is on the unit circle, the sine of theta is just going to be the y value. So the y value here is 3/5. And I'm done. Okay, if I want the cosine of theta, since this is a unit circle, it's just the x-coordinate. The x-coordinate is 4/5. Now if I want to find tangent, tangent is actually y over x. Okay, so the y value is 3/5 over the x value is 4/5. Okay, the 5's cancel out, so I can simplify this down to 3/4. Okay, now I'm going to find the reciprocal ratios. Okay, cosecant is the reciprocal of sine. Because I know that sine is 3/5, then cosecant is the reciprocal. So I can just make it 5/3. I don't have to do 1/y and all this stuff. If I know one answer, the other one's the reciprocal. The reciprocal of cosine is secant, so 4/5, 5/4. And for cotangent, I could do x over y again, or because I already know tangent is 3/4 and I know cotangent is the reciprocal of tangent, then cotangent would just be 4/3. Or I could also do the x over the y. Okay, so for example 3, we're going to evaluate the trig functions using the unit circle, except now we're going to include other functions besides just sine and cosine. Okay, and because my other unit circle is far away, I copied and pasted one here. Okay, if you just Google unit circle, this image or some similar image will come up. Okay, let me look at this one. I want to find the cosine of 2 pi over 3. I know that the cosine is the x value, so let me just locate 2 pi over 3 on the unit circle right here. The x value here is -1/2. So the cosine of 2 pi over 3 is -1/2. Okay, now let's think. For the secant of 2 pi over 3, the secant is the reciprocal of cosine. Because I know that the cosine of 2 pi over 3 is -1/2, the reciprocal of -1/2 is going to be -2/1, and I am going to simplify that down to -2. Okay, the last one's tangent of 2 pi over 3. Tangent, if you recall, is y over x. Okay, so let me look back at 2 pi over 3. At 2 pi over 3, the y is √3/2, and the x is -1/2. Okay, the 2's do cancel, and I'm left with the negative and the square root of 3 as my simplified answer, and you should always simplify your answers. Okay, let's try the next ones. Okay, let's see, where are we at? We look like we're at 7 pi over 4. So where is 7 pi over 4? 7 pi over 4 is right here. I think I'm going to write the ordered pair on the side so I can stop looking up and down and up and down. Okay, 7 pi over 4 is, the ordered pair is √2/2, -√2/2. This is the x, this is the y. Okay, so if I want the sine of 7 pi over 4, I want the y value. So that's just -√2/2. Okay, the cosecant of 7 pi over 4 is going to be the reciprocal of the sine value. Since I already know the sine value, let's just flip that one. Okay, can I leave it like this? No, I can't leave a radical in the denominator. I need to simplify it. So let's rationalize it. What is that? -2√2 over the square root of 4 is 2. Okay, then the 2's cancel, and this goes all the way down to -√2. So the cosecant of 7 pi over 4 is -√2. Okay, and then we want cotangent. I don't have tangent, so let's look. Cotangent is x over y. Okay, so in this case, the x coordinate is √2/2. The y coordinate is -√2/2. So if I divide those out, they pretty much all cancel and I'm left with -1. Okay, the next one is at pi over 2. Pi over 2 is one of the easiest ones to memorize, but let's go back. Okay, pi over 2 is up at the top. The ordered pair up at the top is 0, 1. So let me write down the ordered pair as a note, and then we'll try to evaluate it. Okay, so the ordered pair is 0, 1, so the x is 0, the y is 1. So if I want the sine is the y value. So the sine of pi over 2 is just 1. Okay, if I want the cosecant of pi over 2, that's the reciprocal of sine. So if I flip 1, I get 1/1, which is still 1. Okay, let's see, tangent y over x. The y, 1 divided by 0, oh, that's no good. That's undefined. If you try it on your calculator in radian mode, it's going to give you some lovely error. Okay, the last one we're going to practice like this. I'm giving you a negative. Okay, these are all negative 5 pi over 6, so let's figure out where negative 5 pi over 6 is. Okay, I know where positive 5 pi over 6 is, but that's not going to help me. Okay, let's consider this. If I'm negative, it means I'm going to go down instead of up. Okay, pi over 6 is this big, but I want to go negative 5 pi over 6. So from here, I want to go down 1 pi over 6, down negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6, negative 5 pi over 6. So this is actually equivalent to negative 5 pi over 6. It's coterminal, has the same ordered pair, which means this is the ordered pair I'm using for negative 5 pi over 6. And I'm going to go ahead and write that down below so I don't have to keep looking. Okay, so that was negative root 3 over 2, negative 1/2. I was in quadrant 3. So this is the x, this is the y. Okay, let's see if I want the x value for cosine. That's negative root 3 over 2. Secant is the reciprocal of cosine. So if I know the cosine is negative root 3 over 2, let's reciprocal this. And I'm, of course, not going to leave it like that with a radical in the denominator. Okay, negative 2 root 3 over 3 times 3 is 9. The square root of 9 goes down to 3. This is a better answer because it's rationalized. Okay, and then tangent is y over x. So I get negative 1/2 over negative root 3 over 2. See, the 2's cancel, the negatives cancel, so I have 1 over root 3. But of course, I would not leave that radical at the bottom. So root 3 over 3 times 3 is 9, and then when I square root it, it goes down to 3. So for the tangent of negative 5 pi over 6, I get root 3 over 3. Okay, a couple more fun facts about cosine, sine, and tangent. Okay, the first one is cosine and sine are periodic functions. The period of cosine is 2 pi, and that's because after 2 pi, you end up coming right back around the circle to where you started from. That's why they're coterminal. That means the cosine of pi is going to equal the cosine of theta plus 2 pi n. So no matter how many times you go around the circle, if you end up at the same spot, you have the same cosine value. The same for sine. If I start at theta, I can go around 2 pi n times, but since I end up at the same spot and at the same ordered pair, it will have the same y value and therefore have the same sine value. Okay, and the last fun fact is about whether they are even or odd. Okay, it's not really that you have to memorize it, you need to understand what it's saying so that if it came up, you could find a short way to get your answer. Okay, so I'm going to arbitrarily pick a point t. Let's call this t. And then I'm going to make, if this is t, then negative t must be down here. This is so I can make generalizations about these functions. Okay, what's the first fun fact about this? Okay, so if I want the cosine of negative t, and I want to compare it to the cosine of t, for the cosine of t, the x value is positive. For the cosine of negative t, the x value is still positive, and they're actually the exact same x value. So the cosine of negative t is the same as the cosine of t, which makes this an even function. Okay, it also is true that the secant of negative t equals the secant of t, because if it's the reciprocal, it's still the same thing. This has the same even odd functionality to it. Okay, now I'm going to consider the sine of t versus negative t. Okay, the sine is the y value. So if I look at the y value of t, it looks like appears to be positive. If I did the sine of negative t, it would be negative, but it would be the exact same distance. So the sine of negative t is the same as the negative or the opposite of the sine of t. Because when I plug in a negative, I get a negative result. This makes this an odd function. Okay, and if I was using cosecant, because it's reciprocal, the same would be true. If I plug in negative t, it would give me the opposite sign for the cosecant of t. Okay, now for tangent, because tangent is the y over the x or the sine over the cosine, it's going to result in a negative as well, which makes tangent also an odd function. Okay, these little tricks can sometimes help you evaluate functions by doing less work, but there's always other ways to do it if that's not your favorite. Okay, so for example 4, it says the sine of t is 3/5 and the cosine of t is 4/5. What is the sine of negative t? Okay, if you recall, the sine of t versus negative t, they have opposite signs because it's switching signs. It's going up different positive y, negative y. So if the sine of t is 3/5, then the sine of negative t would be negative 3/5. Okay, now if I consider the cosine of negative t, because the cosine of t is 4/5, and the cosine of negative t should be the same as the cosine of t, then it should be that the cosine of negative t is also 4/5. Okay, that's how we use it for some arbitrary value they give me, which we will do more of in the future. But we often also use this for the unit circle. Okay, sometimes this makes it easier to evaluate functions, sometimes it doesn't. Okay, so if I want to find the sine of pi over 6, I could go backwards on the unit circle and find the sine of pi over 6, or I could use this fact to find the answer. Okay, so if I'm using the odd feature of sine, if I go to positive pi over 6, the sine value is 1/2, which means the sine of negative pi over 6 should be negative 1/2. Okay, if I didn't want to use the property and I wanted to just figure it out on my own, I could have also said I'm going to start from 0, I'm going to go to negative pi over 6, and I'm going to look at the sine value here. It's negative 1/2. It gives you the same answer. It's just trying to give you different options on how to evaluate it. Okay, so if I want the cosine of negative pi over 6, now, because it's even, I know that it should be the same as the cosine of pi over 6. So if I look at pi over 6, I can see the cosine is √3/2. Okay, so that's one way to find the cosine at negative pi over 6. But again, I could also start here and go to negative pi over 6 down here and then look at the x value there. And it is the same. It's just giving you some different options. Okay, last example is example 5, and it's going to use the fact that these are periodic functions to evaluate the function. Okay, I'm going to show you the long way, and I'll kind of show you the short way to figure this out. Actually, it depends on your mood which way is the short or long way. Okay, if I want 9 pi over 2, 9 pi over 2 is not a point that's on the unit circle labeled. I have to kind of figure out where it is. Now, I could just count it over and over again until I get to 9 pi over 2 and then figure it out from there. So for example, if I start from 0, this is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, I end up here. I want the sine value, so the y coordinate here is 1. So I know the sine of 9 pi over 2 is 1. That's one way to figure it out. Okay, the other way would be to know that this is a periodic function. So I went around way too many loops here. I want to figure out how many extra loops I went around. Okay, so let me think. Let's see, each period is 2 pi, which is like 4 pi over 2. Okay, so I went 4 pi over 2, 8 pi over 2. I probably went around twice. I went around twice to get to 4 pi or 8 pi over 2, plus I have an extra pi over 2, which means that the sine of 9 pi over 2 should be the same as pi over 2, which happens to be 1, and I could get the answer using the fact that it is periodic. I could also just start with 9 pi over 2, and I could subtract 4 pi over 2 till I get to an answer I like. So I could go 9 pi over 2 minus 4 pi over 2, that's 5 pi over 2. Let me subtract 4 pi over 2 again. That takes me down to pi over 2. Now I can evaluate it from there. Okay, but if you just know the facts, it does help you kind of figure out where to take this from. Okay, now 22 pi over 3 is way too much for the unit circle. Let me consider this. Okay, 22 pi over 3. 2 pi, what is 2 pi? 2 pi is the same as 6 pi over 3. Okay, so one way I could do this, I could take off 6 pi over 3 till I get a low enough number. And I could do this in my head. This takes me down to 16 pi over 3. Let's see, subtract 6 pi over 3, now I'm down to 10 pi over 3. Take 6 pi over 3, I'm down to 4 pi over 3. Okay, so this is the same as the cosine of 4 pi over 3. 4 pi over 3 is on the unit circle. So if I go to 4 pi over 3 and look at the cosine or the x value, I would get negative 1/2 as my value. Okay, that's one way to do it. You could also go to your unit circle and count to 22 pi over 3. This is, let's see, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3, 12 pi over 3, 13, 14, 15, 16, 17, 18, 19, 20, 21. Where am I going to? 22. 22. Takes me down to 4 pi over 3, and I can see from there that the cosine is actually negative 1/2.